You have Minecraft there. So imagine if you were able to create actual physical objects or physical characters from your Minecraft characters. How cool would that be? So imagine taking the world of online Minecraft and creating.
So you can make like.
Yeah.
So you can make
Here's some samples. This is a Minecraft castle. This is somebody who made something on Minecraft. You can pass it around, and all of a sudden it becomes real.
So you can make like a Minecraft movie, pretty much.
Yeah, you can make. There's another creeper going around.
That is Minecraft. Yeah.
Yep, that's definitely Minecraft. So all of a sudden you got a tool in your hands. In fact, that fits on a table like this. That helps you make just about anything. So who has seen actually a 3D printer before, in real life, not on video, in real life? First one, okay, where did you see it?
I saw it, I went to a summer camp and I was at this school and we went into this resource classroom I think and they had one just in a corner in case they needed to use it.
Okay, so you saw it work and make something, what did it make? Just curious.
Oh, well, I didn't see it make anything, I just saw it sitting there.
Okay. Well, who would have figured a 3D printer would be this small, right? Did everybody think it was something a lot bigger or a lot more expensive?
I thought it was
totally.
like this tall.
Yeah, exactly. Well, they used to be that big, and now they're getting smaller and smaller. There's one, I think I've seen it about this big.
So like the size of a regular printer?
Yeah, absolutely. And not only that, the cost is going down, so you can get actually a 3D printer for about $500 now,
I'm saving up.
which is ridiculously cheap when you think about it.
I'm saving up.
So, yeah, so this was about $2,500. We bought it a few months ago, and this actually, we take it around on a road show. We go visit libraries, we visit schools, we visit community centers, and we give demonstrations. And we want to get people excited about 3D printing, and maybe teachers, like your teacher, would say, hey, we would love to get a 3D printer in our school.
I would love to get a 3D
So wouldn't that be great to have one in your library, or your computer lab, or your art class, or your house? And that's one day, who knows? So I'm going to tell you a little about how the 3D printer works, and also going to give you some examples of what can we do with a 3D printer. So you can print lots of stuff. So remember when I said you can print anything that you can imagine? Well, here's some people who decided to. I hope this works. I think it's getting a little slow.
Can you print an Ender Dragon? No. Maybe.
So I'm going to
like a Minecraft Ender Dragon.
So this is actually chocolate being 3D printed. So
no
I want you to take a really good look at what's going on right now. So what's moving around? Go ahead.
It's a machine that's kind of squirts out chocolate and then makes it harden.
Okay, that's really good observation, because that's exactly how this type of 3D printing works.
Well, hold on a second, I'm going to get a close-up on it.
So, for some reason it's not continuing, but that's exactly what's happening here. There's a nozzle, as you can see. What you don't see is chocolate being fed through this nozzle, being warmed up, because you don't want the chocolate to get too liquidy, right? So if we heat it up too much, it's going to come out like a liquid.
So you still have to give it like a source of chocolate to make it, right?
Oh, absolutely, absolutely. So the source is very important, the source material. But basically what it's doing, it's following a pattern, as you can see. Obviously a simple pattern.
Can you make whatever pattern?
Yes, and we'll talk about that. So there's simple geometry, just a square shape, and the chocolate 3D printer is just going round and around, and as you mentioned, it's putting a layer, just like icing on a cake, right?
That looks good.
So see, it's not super fast, and it's not meant to be super fast.
Beautiful.
You probably wouldn't be able to go much faster than that. And the key is actually that it's melting, but it's hardening at the same time, because you want each layer to stick to the layer below it. Otherwise, the whole thing would just kind of harden, right? But this shows the principle of this type of 3D printing, which is called a filament type of 3D printer. So in the back of this 3D printer, instead of having chocolate, I have a plastic wire. Okay? So this is what feeds the nozzle that you're going to see in the demonstration here.
Chocolate.
How do you put the chocolate?
How do you put the chocolate? In this case, it's not. I don't think it's wire. I think it's
chocolate.
just a block that's kind of melted a little bit. And it just it's the pressure.
Just like maybe like in a tin.
Yeah, exactly. I'll show you another example of this. We're going to stick with food for a second.
Woo! Could you make what do you call it?
So this is NASA. Everybody knows NASA.
Yeah.
Okay. Yes. So on the International Space Station, astronauts are there for months and months at a time. Food can get a little bit boring,
So they make pizza.
right? Exactly. So
Why
imagine
not?
if you can make your own food
Let's do it.
on the International Space Station using 3D printing. It sounds crazy, but
That's right.
this is a
I would
prototype
try if that could
3D
happen.
printed pizza.
of a
Let's watch
machine
it.
that can actually
So how
make...
close
That's
is this to
fast.
what the actual model you think will look like?
Well, we want to, if we
That's going fast.
Same principle.
continue with NASA, there's some
See-
other, we want to create a zero waste
This is
model,
moving
because we
around the
want
bed.
space to not have any
The printer
food
seems
or
to,
other byproduct
yeah, just
waste.
depositing
We're gonna have
dough
to
and
add
sauce
various systems to that,
and
we
whatever
are
else
also
goes on
looking
pizza,
currently
cheese,
on
yeah.
a mixing chamber design. Right now we mix the raw materials themselves and add it to
If
machine.
you want to get creative, why
Mm,
not?
pizza.
The machine will do what
So 3D printing is used in all sorts of things. And I'll show you one more example, which I think is a really nice story, is... So I'm going to show this little boy who was born without a hand.
Michelle Miller shows us how the idea of a modern-day inventor became a 3D reality.
Grabbing a backpack is hardly the feat of a superhero, unless you're 12-year-old Leon McCarthy and your hand looks like it's straight out of a science fiction movie. You've actually become sort of a cyborg robot. There's a cool fact.
Yeah, it's like a special. It's special instead of different.
Leon has been special since birth. While he was still in the womb, restricted blood flow prevented his hand from developing.
I saw his hand sticking up and there were no fingers on it. It was hard for my wife, it was hard for me.
2 years ago, his father, Paul, began the search for an inexpensive, functional prosthetic. What he found was this internet video posted by Ivan Owen, an inventor in Washington State.
I've always had this vision of people being able to build their own prosthetic device at home.
Owen and a collaborator in South Africa designed a hand that could be made by a three-dimensional printer.
The picture in the back, it's the same one as this one.
It's essentially like a hot glue gun. There's plastic that feeds into it. The printer head gets really hot, and liquefies that plastic, and then layer by layer creates an object.
The design relies on wrist movement. Downward motion creates cable tension that closes the fingers, while a move upward opens them. The assembly instructions were posted for free on the internet, so someone like Paul McCarthy in Marblehead, Massachusetts, could print it. He took the idea to his son.
I thought he was a little crazy. He was like, we can print all these fingers and then like clip them all in, and it was a little too much.
The first time you saw it, and when you tried it out,
It was pretty awesome. Yeah.
what made it awesome?
I could pick up, say like a water bottle. Like say, I could pick up my pencil.
What is it like to see him with this?
Making your kids happy is like the most rewarding thing you can have as a dad, right?
The price tag was also appealing. Many 3D printers sell for about $2,000. Materials are far less expensive.
This thing cost us like $5, $10, you know, whatever. It was nothing.
What would a prosthesis cost you?
$20,000, $30,000.
The cost allows father and son to experiment with newer designs.
When I outgrow a hand, we can easily make a new one.
It's a do-it-yourself solution that was unthinkable before technology made ideas printable.
That's cool.
Yeah.
Michelle Miller, CBS News, Marblehead, Massachusetts.
That's a really wonderful story, and I like the way she finishes
Is
it.
that awesome?
It makes ideas
Iron Man.
printable. So you don't have to look very far or hard to see all the amazing things you could do with a 3D printer. And that's what we're going to do today. I'm going to start the demo, and I'll explain a little bit how the actual process works a bit. So the tricky part is figuring out what should we do for this class. Any suggestions? I already have some things preloaded. Anybody want to go ahead? Just
A sword.
A sword?
Like a Minecraft sword.
That's what you were thinking? A pickaxe.
A
Okay.
Minecraft Steve.
Minecraft Steve. Okay.
Everyone likes Minecraft here.
I think we're gonna. Yes. Go ahead.
A chest?
A chest. Okay. So just any chest or
Minecraft chest.
Minecraft chest? Yeah.
Rock chest.
A ghast?
A what?
Ghast.
Oh, gas.
Oh, it's a monster. Okay. I'll have to. I didn't even know what that was, so I'll have to look that up. So I guess we're gonna stick with the Minecraft approach here. We'll do a creeper. Okay. We'll do a little bit bigger creeper than normal. So I got some files preloaded here. So there we go. We're going to do a creeper. Now, as you can see, this blue table is moving up. Okay, and it's moving up because there's a little nozzle there that's going to, remember that chocolate 3D printer? The nozzle's going to move around. I'm going to put a little glue here to make sure that our object sticks. You know that other 3D printed creeper going around? That's an example. If you can show that one.
Is it like half of the one that's
That one didn't
made?
stick on the table, so it's very important that the first couple of layers stick. So let's see, I hope this all works good. So I'm drawing, it should draw a test line right now.
Yep.
So what it's going to do, it's going to make the outline of the creeper. Okay, so what I'll do is have the group coming around. The only thing I ask is you don't push the table, because otherwise what will happen is the same thing happened to that creeper. It's going to get
Mushy.
Now I don't know if you can see the outline of the creeper already being made. It's on its side.
Yeah.
Right? So what I'm doing is I showed you the plastic that's in the back of the machine. It's like a wire, and it's being fed to this part of the 3D printer. And what is this part? Well, there's a couple of things. One, there's a way to heat the plastic. Remember, we don't want to heat it too much that it becomes liquid. That would be bad news, right? Because it would just splatter. But it's got to heat it enough just for it to get soft. What's happening? It's a tricky question because what's going on here? You may not notice this. Yeah, go ahead.
It's overlapping the plastic outline and then it's heading taller and taller.
Exactly, so it's overlapping. And how does it do that? See this blue table? It's actually going down 0.2 millimeters every time it makes a pattern or a pass. So this little table is key. It's going down just a teeny tiny bit every time. And all this is doing, this nozzle is moving this way and it's moving that way. You can see it's going like this, right? It's like XY axis, right? So here we go.
It's really high actually. It's like.
And each layer is 0.2 millimeters in thickness. So I'm putting one layer on top of another layer on top of another layer, and it's hardening.
It's 0.6 right now.
So right now this plastic is not super hot. You'll see when it's finished, I'll just pull it right off with my fingers, and there's no problem. So the only sort of dangerous part, you see that little nozzle underneath there? That's very hot. That's about 230 degrees Celsius. So you wouldn't want to stick.
So you burn your hand off. Yeah.
Well, you would burn your finger. You wouldn't lose a finger, but it would just really burn.
You would have to run the sink.
So this is really advanced robotics at work. Because often when you think of 3D printing, you don't think of robotics. But this is what this is. This is really advanced robotics.
Because they're making it specific.
Okay, so how did I get this 3D printed creeper? Who designed this? I didn't. I'm not a very good designer, but I'll show you a link where you can find these designs.
Mojang.
So here.
I thought it would be like simpler, like just putting a picture of a creeper and then that.
Yeah, that's what Yeah, that's what he's doing. He just loads it into this, then does that, and chooses it. Then almost done.
Oh no, we got a little bit. So on the screen, there's a blue screen in front there. What does it say? Does anybody want to read that to me?
Creeper.
Does it say minutes or percentage?
223 out of 220.
That's the temperature?
18%.
18%? Okay, so how much further do we have to go?
4 minutes. About like
20 minutes or so, maybe? So we've got, how many minutes have we been printing already?
Like 4.
Take the camera. 2 maybe.
It should be seen in the front. 4 minutes. So we have another maybe.
Yeah, I'm getting one of those.
Yeah, so this.
I'm saving up for one.
Okay, I'm having
I don't have quite enough.
I'm so buying that.
Okay, you have to back up.
You
have to back up. You still have to back up. You can't just randomly win.
Okay, so everybody have a seat, and I'll tell you a little bit about how do we get something 3D printed. So far I explained a bit how it works. Has everybody kind of got a good idea now how it works?
Some more. It's actually getting tall. It's tall. It looks like it's almost a centimeter now.
Oh, okay, yeah, great. So if we get, it's just called Thingiverse.
1.5
So I'm going to show you this really cool website.
Thingiverse.
Anybody heard of Thingiverse before?
Yeah.
It's like a play on words,
yeah.
like universe, but instead it's things, a universe of things.
Oh, and sit down.
Mr. Moore.
Whoa, where'd you get that?
Sit down a little bit.
That's a small creeper. Yeah, that was a.
Oh. So is that what it'll look like, but a little bit bigger?
This one's a bit bigger. The one we're making is a bit bigger.
that little gap. What is its eye? That one is done.
And it's not.
No, we can't. These are samples because I'm going to go visit other schools as well. But you know what? The one I'm making here, I'm going to donate it to your teacher so he can have it in the classroom. And
And we
guys
can get
talk
one of
about
these?
it. Okay, so this is a very cool website. So this company is called MakerBot. It's kind of play on words on robot and making. And they have this website called Thingiverse. And you think, okay, what is that? Well, there's people all over the world who love to make 3D models of things, including Minecraft stuff. So I can go to this website and I'll type in, so what were some of the words you guys mentioned?
Gas.
Dave?
Gas.
Minecraft story.
Yeah, there's one I never heard of.
Gas.
Oh,
Gas?
gas.
How do you spell that?
It's like ghost spelled with an A. It's ghost spelled with an A.
Yeah.
Instead of an O, it's an A.
Okay, so gas, G-A-S-T, like that?
Yeah.
Okay, so let's see what happens here.
There's gas.
Okay, so
Minecraft gas.
what's happened is that there are people who have
That wasn't
printed
Enderman with a gas, though. You can make a lamp.
these Minecraft gas. So they created the models already. And that's my starting point, is a 3D model. So that's something you do on your computer.
Actually, want Enderman.
What's another one?
Enderman.
TARDIS.
Okay, well, TARDIS is very popular.
There's an Enderman right there.
It's good.
There's a TARDIS.
Oh, it's a TARDIS.
I printed the one, I think, down there before, one of these actually. So again, people have created these 3D models, okay? And this is what I find is really cool. They're sharing it for free. So the rest of the world can download this. And that's what's the key here.
Can you make it into a lamp or something?
Yeah. And I'll tell you a little bit. So these are pre-made designs.
Excuse me.
Yeah.
I want Enderman. Let's see Enderman.
Okay, how do you spell that?
E-N-D-E-R.
There was an Enderman in the last one. The picture on the top right corner, there was an Enderman. But it was purple. Yeah, it was a purple Enderman. See, there's an Enderman right there.
Is that it on the right? No?
Yeah, it's the purple thing.
This thing.
I mean, it's kind of like it.
It's kinda like it?
It's purple and it's
Does
holding
that
a
look
gas.
familiar? Okay, it's holding the gas.
Actually, it's black. It's black.
Okay, but that's the basic idea.
And it looks more like Slenderman.
Yeah.
Ender Dragon.
Ender Dragon. Let's see what people give for that.
So how do you spell that?
E-N-D-E-R
Yeah.
and then dragon.
2 words?
Yeah.
Okay, so let's see if they can find one of those here. So it looks like somebody created
It's already recording. Just hold the camera.
the Ender Dragon. I have never seen an Ender Dragon. I didn't know it was created, a 3D model was
It's
created.
like a boss, kind of like that.
Okay, cool.
Yeah, if you jump into the portal, it's the end of the game.
The
It's
thing
how
with
you
this
end
is
the game.
I can download this.
End.
And actually, I haven't tried to 3D print this, but maybe someday I will try it just for fun. But the point is here is
I might get one of
that
those.
people are creating these designs and sharing them for free online. So even if you want to just start off with 3D printing and you do not know how to do a 3D model, you can download a 3D model. But it's a great way to get you excited about making your own 3D model. Because I know you have a project on creating a toy.
Yeah.
And I'm not too sure 3D modeling or prototyping is part of it. Oh, was I supposed to?
That's all right.
Okay, yeah. So,
Second semester, guys.
second semester. Well, I'm really sorry, yeah. So,
It's all good. It's all good.
so creating your own 3D model, there's 2 ways of doing it. One is using software, which I'll show you maybe an example or two. The other one is using a scanner. Now, scanners are becoming very popular, and these are using lasers to scan an existing object. So take any object like this egg, I could place it on a scanner, and it'll scan it 360 degrees around, and then create a model like that, a 3D model. Where do I get the scanners? Well, they're not free, unfortunately. They're starting to sell scanners now for your desktop. So you can get a scanner not much bigger than this, and put it on your desktop, and it'll scan a pretty good sized object. Yeah.
I saw a YouTube video where a company was developing a scanner for an iPad.
Oh, yes.
And they attached it and plugged it in, and it scanned like the room
Yes.
in 3D.
That is very cool. That's a really good observation. That's one of the technologies. Probably not a plastic iPad. Maybe a frame. But that thing about it's attaching a little instrument to your iPad, and you can scan using your iPad, which is pretty cool.
Is that right?
Yeah, that's very cool. Yes.
And you can switch.
Yeah, that's a great question. So I was asked,
color midway.
can you make 2 colors? Not with this machine, but there are other machines that you can have more than 1 color. So there's another model of this that has a second thing that you can put 2 colors together.
Could you not just switch it midway?
It gets really tricky. I haven't tried that yet, and I'm not sure I want to try it. I don't think it'll work with this one, probably. It would be, yeah, I don't think it would, but with other 3D printers it could work. Okay, so we talked about downloading a 3D model, scanning an object, and then the third one is a software. Now, amazingly, there's some free software you can download and create your own 3D models of anything. You start with simple geometry, circles, triangles, and squares. And think of it, you can make so many things with it. Think of Minecraft. If you just think of small squares and small triangles and small circles, you can create all sorts of objects. So there are really easy programs to learn how to create a 3D model.
You could just make holes.
Okay, so now that we got our 3D model like this Ender Dragon, how do we tell the 3D printer how to make it? Just because we have a 3D model, yeah, go ahead.
It's on a grid, so you could tell them what angles and the amount of thickness on which grid square.
Right, exactly. Because the 3D model right now it's just a lot of math, right? It's a lot of, this line goes this far, that line goes that far, that line goes that far. This is all math, basically, all geometry.
I want to get one.
But now the machine doesn't understand all those instructions. It has to be told, you have to slice this object in layers, right? Because that's what we're doing. We're printing layer upon layer, right? A 3D model doesn't have those instructions. So you have to convert this model into a machine-readable file. So it's called G-code. The G-code is very important. G-code is the type of code that drives a lot of machines, especially in manufacturing. Because this is a manufacturing machine. So it would take this model and create layer upon layer upon layer. In fact, what I got on the laptop here is, oops, it just disappeared on me, is this lady here. And what I can do is, and I can create, let's see, I think it's...
How long would it take to make one? Like one of these?
So right now I'm going to tell it to create a...
But won't it stop that?
No, because it's not connected. But basically, what I won't be able to do it here, but it'll take the 3D model, which I have on the grid here, and it'll slice it into probably 500 layers. You know, again, a 0.2 millimeter thickness. And basically, it'll send instructions to the 3D printer. Oh, where's the lady? There she is. So there's roughly, if you look carefully, you can see the lines, right?
Yeah. You were supposed to pass.
So I also need to tell the printer how much fill to put in. As you'll notice, it's pretty lightweight. That means I didn't have to fill it up with material, because that would be a waste of material, actually. So I need to tell the 3D printer how many layers, how much fill I need, and the thickness of each layer. So this one's 0.2 millimeters. I can go as small as a 0.1 millimeter, which is really...
How big can you go?
Well, how thin can I go, you mean?
How big? Like how thick?
0.2 is the maximum, actually. So it's 0.1 or 0.2. Now, the size of the object is limited by the size of this printer. As you can see, I don't have a lot of room, but I can make an object about this wide, this high, and maybe this deep. But I can also, that would take a long time. That would be like a 12-hour print job, probably.
And you just do it while you're drawing, like, all day.
Yeah, exactly.
Overnight.
I'll give you an who's been to Calypso Water Park here? Okay, so you know the water slides, right?
Yeah.
So did you know it's a local company that makes those water slides?
Yeah.
It's called Pro Slide, and they use 3D printing.
Oh, really?
Not to make...
Is that the cheapest one?
No, it's not the cheapest one, but it's among the cheaper ones. But it gives you an idea of just... oops, there we go. So you can see it's not as clean looking as this one, but it works perfectly well, and it can do exactly what you see on that table of samples over there.
Everything there?
It can do everything there.
And so how much would this one cost?
This machine is about $2,500.
What's the difference between these two?
Yeah, so you can see.
You can make
just look at the frame of this 3D printer. This one has sort of like a aluminum. It's kind of a nice. Yeah, it's a nice looking. So this one's kind of bare bones sort of structure.
It's still just as good,
but yeah, exactly. So the nozzle here works exactly like that one. Whoops, and then you can kind of, oops, I kind of went back. How do I go back? There we go.
Junior belt.
Yeah, so.
That was the version 2.
That's the version 2. Yeah, there's a version 1.
Is it version 1?
Is it about the same size?
Yeah, it's about the same size. Yeah, here we go. There's different looks of it right now. The printer bought, so, oh, by the way, yeah, the filament's the same size. So that wire is 1.75 millimeters thick. This is standard plastic that you use in cutlery in restaurants. You know when you go to the restaurant, they get plastic cutlery or at the cafeteria?
You can make a plastic cup?
That's the same. Yeah, I can make that. But the material is that kind of plastic. And it's biodegradable, so it's more environmentally friendly, which is good to know.
So, like,
yeah.
if you ever want to throw it up, put it in the compost bin, don't actually throw it out.
Make like a fake plant and like put it in the and then it would, like,
So,
and then it like die for like
check. It's a check.
so in the United States right now, there's a big movement to try to get 3D printing in schools.
I want to get one.
And I think educators are getting more and more interested in saying, hey, you know, would my students be interested in having a 3D printer and making stuff?
Definitely.
I think there would be a lot of interest. And
like if you ever want to make like in class, like if you need to. Like,
yeah, you could make your 3D graphs.
Yeah, you can make like a graph, like a bar graph. You can make bars.
Yeah, you can make. So again, think of your imagination of things you can do, and you have resources on the web that if you come up with something, I would bet somebody else somewhere in the world has also thought of the same idea or something similar, and you can get some help in how to design something.
You can make a tiny house, like a tiny house.
Well, speaking of houses, here's another crazy use of 3D printing. Somebody's actually creating a 3D printer to build shelters. So when the hurricanes strike countries or cities and people don't have or have flimsy tents as shelters, he's thinking of a way to build large shelters using 3D printing. It would take 20 hours, according to this one inventor. So this is a university professor in California who's working on using concrete as the material.
Really?
And using that principle of the nozzle and layer by layer, creating shelters. So think of it, a concrete shelter would be a lot more durable, sturdy, particularly during emergencies that we hear so often about. So I think that's a great application of 3D printing. So you saw biomedical applications, the prosthetic hand. Yeah, go ahead.
So how big would the printer need to be to make the structures?
It's a pretty big 3D printer, let me tell you.
Like
when I saw
one of the big old-fashioned one like that.
Yeah, but it's mobile, so it's something that you could put on a flatbed truck or something, move into position.
Can you make a bed if it's big enough?
I guess you could do a bed frame, so you could do different components and fit them together. So don't forget, it's not making all things in one shot, in one piece. You can make multiple pieces and then join them together. So for example, this nut and bolt over here, this is a good example. This was made with a 3D printer. Did anybody?
Whoa.
So this was made using this machine. The bolt is perfectly fine. And you can see it's threaded inside. So if you look carefully, this is actually a working nut and bolt. So you can actually piece things together or
so you could like make.
It's amazing.
I think I need one of these.
Yeah. I do need one.
But I definitely need.
How are we doing for time?
We're good.
We're good? Okay.
I don't think
So how are we doing on the time and
88% in 21 minutes.
Okay, that's great. 88%, so we're almost there.
Is it like 30 minutes to make one?
Yeah, this one's, I usually don't make this one, but I think we had more time today, so it gave me a chance. So far so good, but did you notice that I'm not filling up the creeper? Yeah, it's only 10% filled. And here's a really important part about 3D printing. Most manufacturing, you take a block of material and you cut away the material to make the piece, right?
Right on top
That's
there,
the way that
so
most things are made. 3D printing is the opposite. It only uses enough material to make the object. So there's nowhere near as much waste of material. So again, think of that. Most manufacturing is cutting away material